We've been talking a lot about equalities and equations, and now we're going to talk about inequalities. When we talk about inequalities, the most inequal, sorry. When we talk about inequalities, the most interesting inequalities are not when something doesn't equal, but when something is greater than, less than, greater than or equal to, or less than or equal to. Some notation: when we say x is greater than 3, I prefer thinking of a number line, marking 0, going to positive 3. And then if it equals something, we're going to draw a closed dot. And if it can't equal that thing, we're going to have an open dot. And if you have your variable first, you're then going to point the direction of the inequality sign, and that will show you all the places on a number line where x is greater than 3. Right here is the number 4. 4 is greater than 3. 5 is greater than 3. 4.5 is greater than 3. 3.5, 3.2, 3.1, all the way up to 3, but not including it, is greater than 3. The textbook that we're using is going to use a parenthesis and then point that direction when it can't equal. I like that because that's going to help us get ready for what's called interval notation. So here's a graphical display of x is greater than 3. Here's an equation showing x is greater than 3. And here's what interval notation looks like. It says you start at 3, but you don't include it. That's why we have a parenthesis, and you go forever. Positive infinity. The way you draw an infinity is you draw a sideways 8, and then you don't have to say positive infinity, but it never hurts to confirm that we're going to the positive side. With interval notation, we always start with the smallest number on the left, and then we go to the positive number. To the biggest number on the right. In this case, there is no right bound. Let's try another inequality. This time I got a number line for you. If I said graph that x is less than or equal to negative 3, let's say negative 2. So I put 0 here, negative 1, negative 2. To graph that, I'd put a closed dot, clearly showing me that it's circled in. Because my variable is first, I can just show the arrow going in the direction of that inequality symbol. This says the exact same thing. Negative 2 is greater than or equal to x. But because my variable isn't first, I don't draw the arrow to the right. I have to think about where are the values of x smaller than negative 2. That would be over here at like negative 5. Good? To practice with interval notation, start with the number that's all the way on the left. Well, it goes forever in that direction, so you would draw a negative infinity. And then it goes all the way up to negative 2. Now, it can never be negative infinity or positive infinity, so that will always be a parenthesis. But it can equal negative 2, so we show that with a bracket. Our book will graph this exact same inequality this way. Do you see how that bracket is nice because it kind of shows you where what you would use with interval notation. So let's try another example, just graphing inequalities and writing them out in interval notation. Another example might be something like this. If I said negative 3 is less than x, which is less than or equal to 4. All right, so now I'm going to put 0 here on my number line. I'm going to take this in 2 steps if I want. First, I'm going to take this part, that negative 3 is less than x, and I'm going to graph that. Okay, I'm going to flip that around, and it's going to say x is greater than negative 3. Good, just flipping the way that looks. You flip the inequality sign because you're just writing x first. I still think of my third grade teacher, Mrs. Bruce, who told me the alligator eats the bigger one, right? X is bigger than -3 because the alligator wants to eat it. The alligator still wants to eat X. So I go to -3. I put an open dot, and I want all the values that are bigger than -3. Now I'm going to look at this other half of the inequality. This says X is less than or equal to 4. So 1, 2, 3, 4 is right here. I'm going to put a closed dot at 4, and I'm going to go this way. So now it's all these values in between. It can't be anything over here. Well, that's less than 4. It's not bigger than -3. It can't be anything over here that's bigger than -3, but it's not less than 4. The answer for X would be anything in this range. To write that in interval notation, you would use a parenthesis for -3. You would go all the way up to +4, where you would use a bracket. So all three of these say the exact same thing. This inequality here, written with X and inequality symbols, is the exact same thing as this graph of those values, with the open and closed circle in the right spots and everything highlighted in between. And that's the same thing as this interval notation. So you want to be checking that you can write the inequality, that you can graph it, and that you can write an interval notation. The next thing you want to be able to do is solve inequalities just like you would solve an equation. So -3 times x plus 2 is greater than 2x plus 7. Don't even worry about the inequality symbol for a second. Just pretend it's an equal sign and do the work that you would do to solve it if it were an equal sign. -3x plus -6, 2x plus 7. You would then maybe add 3x to both sides, subtract 7, or subtract 2x, add 6. I'm going to subtract 2x from both sides. And I'm going to get -5x minus 6 is greater than 7. I'm now going to add 6 to both sides. -5x is greater than 13. Now I'm going to divide by -5. And I'm going to get my final answer, which is x and -13/5. When we solve inequalities, you have to keep the inequality sign facing the same direction unless you multiply or divide by a negative number. Because I divided by a negative number, this flips direction. I know that seems weird, but let's take some inequalities that we know are true. 100 is greater than 5. -7 is smaller than 12. You would much rather have $100 than 5. You would much rather have 12 than owe somebody 7. Now the rules that we use when we solve equations say you can add by whatever you want, you can subtract by whatever you want, multiply by whatever you want, divide by whatever you want. As long as you do it to both sides, everything's going to work out. When you multiply both sides, you multiply every number on both sides. When you add or subtract, you just do it on both sides. But we know that things will stay equal. That's true with inequalities except multiplying by a negative. If I multiply this by a -1, I have to multiply this by a -1, but -100 is not greater than -5. So the only way to keep it true is I have to flip the sign. It's better to owe somebody $5 than 100. If I multiply both sides here by a -1, I get 7 and -12. But again, I couldn't keep the inequality sign the same because it's no longer true if I do that. So 7 is bigger than -12. So when you solve an inequality like we did over here in this red column here, When you solve an inequality, you treat it just like an equation. The only difference is if you ever divide or multiply by a negative number, you have to flip the sign. Now, if we take this final answer and we draw it on a number line, x has to be less than negative 13/5. All right, so let me clear this off. X has to be less than negative 13/5. So where's negative 13/5? Well, if here's 0, here's negative 1, negative 2, negative 3. It's somewhere between negative 2 and negative 3. I don't really care where. It's actually closer. It's actually closer to negative 3. So I'm going to put this value here, negative 13/5. I'm just ballparking it. Open or close circle. And because my x is first, I'm pointing this direction. So we have the inequality, we have the graph, and now let's write the interval notation. What's the smallest number on the left? That's negative infinity. And we're going all the way up to negative 13/5. We can never be at an infinity, so it's a parenthesis. This is an open circle, so it's a parenthesis here. Good? Let's try an example on our own and unpause the video when you're done and see how you did. If I give you the problem, 1/2 x plus 2/3 is greater than or equal to 3/4 x minus 5/6. I know I gave you one with nasty fractions. I did that on purpose. Do your best here. Just like solving an equation, except if you multiply or divide by a negative, you got to switch this inequality sign. Pause the video and try it yourself. Alright, I tried to give you the hint. Just like solving an equation, my first step is to multiply everything by 12. I get 6x plus 8 is greater than or equal to 9x minus 10. And that looks so much easier. So how did I get that? 12 times 1/2 times x plus 12 times 2/3, 12 times 3/4 times x, and 12 times 5/6. Good? Because I multiplied by 12, I don't have to switch the inequality sign. 2 goes into 12 6 times, I get 6 times 1 times x. 3 goes into 12 4 times 2 is 8. 4 goes into 12 3 times 3 is 9 times x is 9x. 6 goes into 12 twice, 2 times 5 is 10, and that minus sign is still there. Now, solving this equation, I'm going to subtract 9x from both sides. I'm going to subtract 8 from both sides. I end up getting negative 3x is greater than or equal to negative 18. I'm now going to divide everything by negative 3. When I do that, I get that x and over negative 3x over negative 3 is x, negative 18 over negative 3 is 6, but now I have to flip the inequality sign. Now look how nice this is and how ugly it started. Just by multiplying by the lowest common denominator, you can clear the fraction, have a pretty easy inequality. Now if that's our final answer, x is less than or equal to negative 6, we go to a number line. You mark 0. If it's really far away like 60, you could do something like, 10, 20, 30, 40, 60. Or you can just do 2, 4, 6. I don't care what scale you use as long as you use it consistently. Can it equal 6? Is my variable first? If so, draw the arrow pointing the direction of the inequality sign. And now, interval notation. Smallest number on the left, all the way up to the number on the right. It can be 6, so it's a bracket. It can never be negative infinity. So you've got interval notation. You've got a graph. And you've solved the inequality as well. A lot of work there. I know you can do it. You guys are great. Don't forget, you've got a test on Friday. This is just to have you working Thursday, working ahead, making sure we're moving forward. Have a good night. Peace.